computers and communications technology. We're now in the early stages of the fourth industrial revolution, which is bringing together digital, physical, and biological systems.
One of the features of this fourth industrial revolution is that it doesn't change what we are doing, but it changes us.
We need a different economic model that will allow us to meet the basic needs of every human on the planet, and that will be focused not on growth per se, but on maximizing human well-being.
We have energy technologies that can power our civilization, but how do we get it and implement it at the scale we need at a price that people around the world can afford?
If we're able to do something to transform cities, to make them more efficient, then the impact can be huge.
We can use asset tracking, we can use IT, we can use 3D printing to decouple growth from the resource constraints we have.
The question of adding quality to quantity, it's really about a diverse, safe, healthy, and just world.
It's serious, but the main question is, how will we define work? How will we share the wealth?
How can you have a doctor that really knows a lot about data? How can you have a biologist that knows about medicine?
We have to create a space that enables people to think freely, to think divergent thoughts, to think creative thoughts.
We really need
this ability of digital technology to change outcomes, to truly empower people that can create a more
Some economists say the world is entering a second machine age. Artificial intelligence and other advancements enabling robots to do tasks that until now only human eyes, minds, and hands could handle. The head of the robotics division at Yasuo, Masahiro Ogawa, seems most excited to talk about robots that don't need to be walled off from humans, that work alongside employees. In the industry, they're called cobots. The International Federation of Robots predicts in coming years, cobots will lead the robotics industry. That's partially what's driving startups like China-based Elephant Robotics to get in the game.
Hit the people, so it will just stop.
Yeah.
So work with people.
Yeah, works with people.
Yeah.
We asked their founder, Ju-Yi Song, how his cobot is different from traditional robot arms.
It moves not that quick, and it is very, very light. Okay. So it can work with people. So this is the most important thing.
In addition to being safer, the collaboration proves to be more productive. A study conducted by MIT researchers found that human-machine groups were more efficient than teams wholly comprised of one or the other. They also reduced human idle time by 85%. Wages for the average urban employee in China have more than doubled since 2008. Rapu, he says, in the past few years, used robotics to reduce its factory workforce from 20.
Robots and factory automation solutions have been facilitating industrial production for over 60 years. FANUC is present in 120 countries, including Hungary, assisting key sectors like the automotive industry, for example, at the Audi Hungary Motor Limited factory in Győr, where they are developing and manufacturing cars for the Audi AG and the Volkswagen Group. Audi Hungary is one of the companies with the largest turnover and export in Hungary, producing 2 million engines and 135,000 cars in 2014.
In our experience, FANUC robots work reliably at our factory. We are constantly improving our production and install robots to reach our targets. In environments where we need to work with high pressure or temperature, the robots are up to the task and deliver quality standards, which would not be possible with human machining. Essentially, robots are used for applications too difficult for humans, or where rapid machining is required. Our colleagues like working together with robots, as they make human work easier by delivering these tasks. It's very important to program these robots correctly, because when problems arise, it's usually not the robot that causes them, but improper programming or the lack of maintenance. Regarding this, I'd like to highlight that FANUC robots are easy to program, dependable, and we have a very good experience with them.
With a footprint equal to 59 football fields, this Amazon fulfillment center is simply mammoth.
We have the packing, the picking, the slamming, the shipping, the receiving.
It's home to an army of employees.
A little bit over 800.
One 6-ton pallet-slinging robot.
We affectionately call it Robo-Stow.
And a squad of box-shuffling cyborgs.
We like to think of it as a symphony between robots and our great associates.
We found a secret at our feet. The floor is covered in tiny QR codes.
It's sort of like a chessboard.
Eyes in the robots' bellies read the codes and broadcast their position. Choreography that keeps your shipment on time and avoids collisions.
They know exactly where to go.
Clicking that yellow button sets these robots in motion. Sometimes within seconds. But your order is not handled by Android alone.
The drive units, the Amazon robots, are actually bringing items from where...
It looks like a lot, and it is. Amazon says those shelves are home to 1 million different items.
1 million.
You think the typical customer realizes that?
Probably not.
We even spotted a toilet in stock.
You name it, we have it.
Chaos and a supersonic conveyor are what we expected. Manager Chris Monnett explained that speed isn't everything.
The important thing is just the flow.
Order levels fluctuate, and yes, there are rush hours. Yet Amazon says its software regulates the line to maintain a steady pace.
In order to have 1 million unique items in this facility, you have to be able to do that.
As gaping, gargantuan, gigantic as this fulfillment center is, it's not alone.
We have 109 fulfillment centers worldwide.
Locally, 59 football fields probably isn't enough either. Our tour guide...
The additive manufacturing process enables us to manufacture parts that we cannot manufacture today with normal, traditional manufacturing processes. That enables us to be more ingenious in terms of how we design our turbine blades, how we cool them and how we life them.
Turbine blades has always been, I feel like, a vision. It's a real target. It's the most challenging area of the turbine. So if you can print a turbine blade, you can pretty much print anything. And we've proven over the last couple of weeks now that we have been able to print a turbine blade and test it in an industrial gas turbine engine.
In Lincoln, we're testing a 3D printed plate, and we believe this is special because it's the first time anywhere in the world this has been tested at full load conditions in a gas turbine. We test these blades very quickly. In 1 hour, we run the engine at full load. We put a probe in here to measure the material temperatures which tell us how long this blade will last in a turbine.
Now, the turbine blade itself is this particular blade. Now, this is the high-pressure turbine blade of a 13-megawatt SGT-400. Typically, we have to do all of the design, analysis, the aerodynamics, the work in terms of heat transfer on this blade 2 years before we can actually then understand in an engine how it's actually going to perform. What additive manufacture does, and this is the additive manufacture blade that we've actually tested in this engine, this gives us the ability to cut that lead time down from 2 years down to 2 months.
It allows us to create new designs, to get more efficient engines, more efficient designs into our turbines, tested, and then onto ultimately our customers.
We will see quicker development times.
You don't need this very expensive tooling in order to make your products. So that makes additive manufacturing perfect for design modifications. You'll get there much quicker.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39, the number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing and my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
This is happening now, today. This is a representation of a D11 steam turbine that's currently running in Southern California. We call these representations digital twins. What you saw was an example of the human mind working with the mind of our machines. What's a digital twin?
Digitalization opens up fascinating new possibilities for the BMW production system. Large quantities of data are generated at many stages in car production. Today, we are already drawing major benefits from intelligent analysis of production data. Our customers benefit from even higher quality. Production uses resources more efficiently, and we are able to manage system maintenance more precisely. Let's take a closer look at the innovative solutions that emerge when our specialists immerse themselves in the virtual world of data. Starting with our new BMW X1, several kilometers worth of steel are used to form parts for the body. But on a 3-kilometer roll of steel, there are bound to be deviations. The material is not equally strong or thick in all places. Some areas have been oiled more, some less. So how can the press that forms the flat sheet into body parts be adjusted to the unique individual characteristics of a cut panel? Here's the solution. Each tailored piece is also known as a blank, is gauged and given a laser marking with data that can be transmitted into the press. The individual parts formed in the press shop proceed to the body shop. Just like in a jigsaw puzzle, these parts are fitted together step by step to create the body. Predictive maintenance ensures reliable operation of a large number of systems. It can also predict breakdowns before they occur. Sensors monitor electric drives for lifts and turntables, for example. Up to 2,000 robots perform welding and bonding operations with maximum precision. Sensors monitor the status of the robot's gears and brakes so they are always fully synchronized. Cylinders and valves in welding guns and welding heads are also constantly monitored and analyzed. As a result, maintenance technicians are able to intervene at exactly the right times. This ensures optimal utilization of production facilities. Sensors also monitor all production processes in the paint shop on an ongoing basis. Through online process control, large volumes of data are structured so that staff can fine-tune processes. Intelligent testing systems ensure the visual perfection of the painted bodies and guarantee the highest level of quality for our customers. Hundreds of bolted connections are made before the powertrain and interior equipment are fully installed in vehicle assembly. Data from the bolting processes, such as tightening torque, is used by quality management staff for systematic monitoring of these processes. Important findings from analysis of this data are incorporated into staff training to help avoid errors. This creates a closed loop of continuous improvement. A single assembly line builds many different models, so it naturally causes problems if the conveyor comes to a standstill. Therefore, a large number of sensors constantly monitor the conveyor system. Data from these sensor kits is streamed live to the BMW Internet of Things platform, where it is visualized and analyzed in real time. If the platform reports a trend indicating deviation from target, staff can decide whether to remove the hanger for maintenance. In this way, it's possible to ensure long-term, reliable operation over a number of years. Our focus is on intelligent analysis of data from production so that we can make the right improvements to our processes and achieve the highest level of quality and sheer driving pleasure.
I think in general all these predictive tools help to increase the uptime and eliminate unplanned downtimes. You need to go step by step. First of all, you need to have connectivity to your equipment at your customer site. From there on, you can collect more and more data and move into a proactive model. But from my perspective, it's a long-term journey over 2-3 years to come from connectivity. But from my perspective, it's a long-term journey over 2-3 years to come from connectivity to remote service to predictive service.
For my product, well, actually I'm in the security area, and for sure it would be good to think about what could be the next step of an attacker. We're working on that so that we can really use machine learning to understand the upcoming attacks better and improve our detection capabilities.
Ion, as MIT's chief scholar on the digital economy.
We used to have to really painstakingly teach the machines step by step, program them what to do, and now machine learning is enabling the machines to figure out on their own how to solve problems. You put together the algorithms, the data, and the computer chips, and you get sometimes a millionfold improvement in the performance of these systems.
A millionfold improvement?
Yeah.
And what does that allow you to do?
So one really important thing to do on the factory floor is just be able to recognize objects, and that's something that only humans could do well until recently.
At IREX, we witnessed a robot handling a task that I, as a human, don't do so well, futzing with one of those pesky tape dispensers. It's among the latest offerings.
Internet of Things today has become a key enabler for enterprises to drive business growth, achieve operational excellence, improve customer experience, and open up new revenue streams altogether. With IoT expected to create a value add of up to $11.1 trillion by 2025, it is addressing the long-standing priorities of key stakeholders across industries, such as getting real-time visibility into changing customers' expectations, improving manufacturing and supply chain efficiencies, and making their organizations smarter, intelligent, and agile. However, to be able to take full advantage, you need to accelerate your IoT journey with the right transformation partner who can address key challenges such as complex data and analytics, diverse platforms and ecosystems. Lastly, when and where to derive business value. Tata.
The technology disruption of digitalization is forever changing the way we make things. And as a consequence, the other big thought, when we make things, we tend to have the capability to innovate things. In other words, if I coexist between what I make and what I research, I will come up with the next best idea. And actually companies like Dow and every company that's, our age is only here today because of that. That we've figured out how to prototype the next thing based on the current thing. And in fact, if I don't innovate faster, then I will be commoditized and be put out of business because the life cycle of businesses has condensed. It used to be that people like us in the chemical industry would think of, I build a plant, I build a factory, it's got a 20, 30-year life cycle, 15-year payback. Forget it. Cannibalization of yourself through innovation, through fast cycle innovation, has arrived. And with modern digital technology, I can do that faster and surer than ever before. Just using robotics and high-throughput experimentation, I've gone from 25,000 experiments a year to 2 million experiments a year. I can shorten the cycle when I deal with a customer on what new footwear design they need for their materials in footwear to give them what they want in terms of attribute. I can do that from first conversation to launch in less than a year, whereas that would normally take 3 to 5 years. That short-cycle innovation is what advanced manufacturing is. It's really actually kind of what Silicon Valley and the whole IT industry learnt and what all the chip makers have figured out. I have the chip. I have it for now. I spend $3 billion making it. And you know what? In 2 years or 3 years, I've got to go build the next one. And what we've got to do is go to high-value, technology-oriented goods, not just high volume. I think the Chinas are solving for that. Everyone understands that actually share of market in today's world is share of knowledge. It's not share of quantity.